Hi there and welcome back. In this lesson we're talking about building blocks. The exam requirement is how to apply the concept of building blocks. So if we go to the TOGAF 9 specification, part 4 is devoted to the content framework and building blocks. And it says, and I'll quote, "A building block is a package of functionality defined to meet the business needs across an organization." So I've underlined here package of functionality. So you can think of either an architecture building block or a solution building block as being the architecture building block is a concept, a logical construct of this functionality. So if, for instance, the customer service function could be a building block. If you've got a product or a service that needs customer service, you could say this box on the screen is relating to customer service. It's a architectural building block. Now, if you've got customer service software, you've got the underlying system that supports the agents that make the phone calls and receive the phone calls, that's a solution. So that's a solution building block. So again, it's a package of functionality that can be plugged in wherever you need it to meet a business needs. Very generic. The other thing is a building block has a type that corresponds to the content meta model. And so the type is it's an actor, it's a business service, like I said, customer service. It's an application, it's a piece of data. Those are examples of building blocks. It's not, the entire department is not a building block. It is a type. Next, a building block has a defined boundary and is generally recognizable as a thing by domain experts. I'm surprised that this wording is in the specification, but it is. But if you looked at it, if you're an expert in architecture and you're an expert in customer service, you'll be able to look at that function and you'll be able to say, yes, there's a boundary there. Customer service begins here and ends there. When a customer service person enters an order into the system for the customer, then we move into the sales function. We don't move into the customer service function, etc. Like you can draw a line and there's no grayness where the boundary exists. A building block may interoperate with other interdependent building blocks. So this is an important concept, is that building blocks don't always stand alone. You can build the building blocks on top of other building blocks, right? So within the customer service building block, you could have the ability to accept inbound calls. You could have the ability to accept faxes, the ability to accept emails, the ability to accept, to do outbound calls, right? All of those sub-functions are also building blocks. So maybe that the ability to receive emails and act on them is a building block that can be reused independently of the phone call function. So these building blocks are as large as you want or as small as you want. You can have building blocks within building blocks. So a good building block has the following characteristics. So it considers implementation and usage and evolves to exploit technology and standards. So in the customer service example, as now people start to tweet and you want to add the ability to respond to Twitter messages to your customer service function, then this building block evolves over time. And so suddenly you've used the customer service building block in a previous architecture. Then once you've added the ability to respond to tweets, then that function is sort of implicitly part of that function. It can be assembled from other building blocks, like I said. It may be a sub-assembly of other building blocks, so the vice versa. And ideally, a building block is reusable and replaceable and well specified. The example with the customer service function is you could potentially outsource the entire function. So everything you've defined as customer service, you can do it yourself. You have your own team within the same building, answering the phones, making the phone calls, responding to emails. And then one day you can say, you know what, we've got this company in the Philippines that are going to do the call service function. And so you don't have to change your architecture. Now, maybe there's some technical things down below that on the solution have to change, but the function of customer service doesn't necessarily change depending on who's doing it. So that's an example. So to sum up, an architecture is a set of building blocks depicted in an architectural model. and a specification of how those building blocks are connected to meet overall requirements of the business. So this is the important bit, is that when you think of an architecture, it is essentially a set of building blocks. So zoom in one level deeper, and you've just got this function the sales function talking to the service function, talking to the database function, talking to this, and these are all just boxes that are talking together. You can zoom in even deeper and see more detail on those. I grabbed this from the spec. I sort of zoomed in. You can see that the phases of the ADM do contain building block components. So this one is phase A. You are doing a high-level model using building blocks, using candidate building blocks, which are not necessarily finalized. You can see that the phases B, C, and D also use building blocks, developing the baseline, developing the target, performing the gap analysis. Those have building block components to them. And the phase E, which is when you associate the gaps to work packages, again involves building blocks. Coming up next, we will talk about stakeholder management techniques. So stay tuned for that. Thanks.